Here we are with part 2 of our exam review video, and now we are talking about a ray bisecting an angle. So SQ bisects angle RST, which means since it bisects, splits into two congruent parts. The measure of RSQ is 2x minus 4. And I want just an expression to get the measure of RST. So RST TSQ would be the same as RSQ. So the measure of angle RST would equal 2 times 2x minus 4. And we don't know what else to do because we don't know how many degrees that is, so we're just simply writing an expression. So it takes 2 of the smaller pieces to equal the larger angle. Okay. Problem 12, we're asked to find the midpoint. So if we remember, the midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So we need to know the coordinates of P, and that's at negative 4, 6. Always the x first. And Q is at 8, negative 6. So make sure you get the coordinates correct first. And then we do negative 4 plus 8 divided by 2. And that'll just give us 2. And we do the y coordinates. Negative 6 plus 6 divided by 2. And that gives us 0. So the coordinates of the midpoint would be at 2, 0. And if we look at that, 2, 0 is this point right here, which looks pretty accurate. For number 13, now we need the distance formula. So recall that the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So make sure you know your x's and your y's. So the length of PQ will equal 3 minus 8 squared plus 8 minus 2 squared. And recall that whenever you square a negative, you get a positive. Now this can be simply typed into your calculator since we want it to the nearest tenth. So 3 minus 8 is negative 5 squared plus 6 squared. And make sure you take the square root at the end. And it turns out to be approximately 7.8. And don't forget, we'll be using distance formula when we're identifying different types of quadrilaterals later in our exam. So for number 14, we're going to look at this diagram, and we have parallel lines, and H is a transversal. So a pair of alternate exterior angles, you have two possibilities. They have to be on opposite sides of the transversal, and outside the two lines. They don't necessarily have to be parallel lines. So your two choices would be angle 1 and angle 5, or angle 2 and angle 6. Alternate exterior. Keeping with that theme of parallel lines or lines in a transversal, the relationship between angle 4 and angle 5. These are between the lines and on alternating sides of the transversal. So since they're inside, they're interior, and they're on alternating sides of the transversal, they are alternate interior angles. For number 6, which statement is true? So FEG FEG is this angle right here, and CBE are alternate angles. No. CBE and DEB are alternate angles. No, they're on the same side. CBE here and DEB are same side interior. That's true. So CBE and DEB are on the same side. And let's just make sure there's no mistake. So FEG is here, and DEB, those would be vertical. So the correct answer is C. For number 17, we have airport runway, 2 parallel runways, and our taxiway. So how are 8 and 4 related? So angle 8, angle 4. If you're having trouble figuring it out this way, you can simply turn your paper. And if we look here, this is in the upper left corner of this intersection, and angle 4 is in the upper left corner of this intersection. So we have two kind of separate intersections. Both are in the same relative position. So they are called corresponding angles. For number 18, again, these are both in the same relative position, so corresponding angles are congruent. So 2x equals 64, x would be 32. Okay. Number 19. We want line P to be parallel to line Q, and we have angle 1 is here, angle 3 is here. So again, these are corresponding angles, so we want to set them equal to each other. Divide by 9, x is 13. And then dealing with slopes, is the line through points PQ perpendicular to the line through RS. So what we need to do is, first of all, find the slopes. So remember, the slope of the line is y2 minus y1, x2 minus x1, rise over run. So PQ, the slope would be negative 13 minus negative 10 over negative 4 minus 2. So that would be negative 3 over negative 6, which is just 1/2. And RS would be 1 minus 4 over 4 minus negative 2. Which would be negative 3 over 6, which is negative 1/2. So one of these slopes is 1/2, the other is negative 1/2. So these are not perpendicular because their slopes are not opposite reciprocals. That is the problem with that. So they would not be perpendicular. So that leads us into the last question of this set, which is what must be true about slopes of two perpendicular lines if they are neither of which is vertical. So the slopes must be not just reciprocals, but they have to be opposite reciprocals, one positive, one negative. If one was a vertical slope, the other would need a no slope or slope of 0 for them to be perpendicular.